All right, so we've done some quick reinforcements, weld, 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 new plate, and some more there. And the reason this is kind of jacked up is because there was a brief moment where I thought it was smart to pound this over and weld it to there, and then I was thinking, well, actually that's a gusset and I need it, so I bit. All right, and now we're getting ready to mat our little mount. I'm gonna try to put those in there, and we'll see if I can squeeze everything in. So I tacked these two pieces together. That way I'll be able to drill the hole through both at exactly the same place. Then I'll be able to saw them off at exactly the same place. All right, so here is our initial guess on where to put the brackets. Basically, I'm up as high as I can. So I went in there and I'd held it with some needle nose pliers to try to get it as perfect as I could, vertically and square eyes. So tacked and this way, tack that in real light. Then I put that in with a washer on each side to give me the spacing that the original one had. And then with the pin through it, I tacked it again so I know that my pin is straight. I have just enough clearance out of my catacron. That could actually, this one's actually more jacked up, and that's the second one. So I could tap that just a little bit in. But with it just like this, I'm going to go and hook it up to my machine, and we're going to see how we can align, if everything's going to work out.
All right, so we're tilted all the way back, maximum thing, and we are pretty good. I can tweak those mounts just a little bit to get this over dead center, but now the real question is if I'm going to be able to get that control box on the top of it or not. All right, so my contraption does fit.
Even if I already cut here, the back of the box is hitting a little bit. They're both at just about the same. So the question is is that angle acceptable, or do I want it closer? And is this implementation good enough? So I just came up with a better idea than all of this. It's even easier. Remember, simplicity rules. So instead of using this like a servo control where it goes to very specific things, I don't know, the chances of me being able to control that to like an eighth of an inch or 16th of an inch and not bumping this while I'm using it and not. So anyway, what I'm going to do is I'm just going to make this forward and backward, like, up and down. And to enable it, I'll just turn it on and off. All right, so now that we're free from having to squeeze a pod in there and figure out some kind of contraption for it, we're back to how to line this up. So we've taken, this is all the way in, and it has a stop on it so that it can't go any farther than that. Now, so I needed to figure out how to put a mount on there where I had a good amount of welding space. So I made up a little cardboard template. Okay. So I tacked the first one into place, and then I went through with some nail polish because it's pretty precise. Like I'm very close to bottoming out there. I want this to be all the way in, and this hits its own natural stops down there. It's the tabs on the mounts. So I wanted it all to kind of come together in a very precise way, and the only way I could really do that is to mark it with everything in place. So I'm going to wait for that to dry a little bit, and then very carefully I'm going to drill with a nice small bit, and then step drill up to a quarter. So that way I'll have absolutely perfect positioning on that pin. And if you're thinking to yourself, Dave, how do you get a drill into there? That's not going to work. And you're pretty much right, except for the secret weapon. All right, so we had it tacked real light, and we just went ahead and, did a little bit here, then went to the other side, did a little bit there. We made sure not to run a solid bead all at once because that would have definitely warped them in some direction. And kind of the proof in the pudding is the pin is still loose after welding. And I made, all right, boys and girls, here we go. The moment of truth. Now, this is kind of the worst case scenario because the motor on there is actually part of the counterweight to help with this. You can almost clear a curb with that. Oh, a full 4 fingers. So, actuator, check. Kind of suck. All right, so we got the engine on. We lifted it up with the, handicapped person live there. We put a couple blocks underneath the axles, and now we're working on balance to see how much it takes to lift that front end up. But my guess is pushing down on this, I'm about 20 pounds, 30 pounds at the end of that. In order to, so it's not really bad. So what I'm going to do is I'm going to take those two car batteries and kind of position them at different offsets on those rails and get an idea of where they have to be. And then I'm going to weld up a mount off of those and down to there. So we have a basic battery platform built up. I have enough room to reach in and hit the levers without really have enough room. And I put in the gussets with holes. Those are going to be lifting mounts so that I can lift this hog around without having to like break my back. Here's your random little tip for the day if you need to plug the end of a thing. So I have this tiny little bit of metal that I got to hold like right inside there without it going in too far. So you just get a piece of wire stuck to it and then let the wire come out and snip it, and now you have a perfect little handle and you can grind off the full knob later. All right, so we put some pieces of wood around, one on each side, and they cup the edges, so that'll keep the batteries from being able to go anywhere. And then I'll put one ratchet strap around the whole thing and make sure that the metal is down here so it can't vibrate against the side. The reason we use the wood tray is because I don't know if these are the final size batteries that I'm going to use. So just having a metal platform, I can put any size wood on there that I want, and it's easy enough. All right, we're going to think ahead just for a second. So the way that the chute rotates, the base is fixed, and then it has kind of a gearing around it, and it only has, half the teeth. I can wrap a sheet of paper around here, I can trace the pattern, then I can carry the pattern around, and I can, this is just plastic, so with a Dremel I can cut these out and have pretty good results, I think. So that way I could have it all the way around. The other option is, this is the friction wheel from the inside of the snowblower, and it's kind of rubbery. It's a little hard. I think I'd want something a little bit softer. But if I were to have a friction wheel that went against this nice plate, just above these screws, and it had like a single thread worm kind of that goes, it's just in a plastic housing. It can pop out of there pretty easy. Not really too keen on this whole mechanism. It's kind of cheesy and light. Also, I don't want to have to put limit switches on the chute control. It's extra wires to run around. A switch can freeze up. Like, stuff can go wrong. Which way am I going to go? I don't know yet. I'm kind of partial to the friction wheel. All right, guys, so what we have here is a small little gear motor, and I'm looking for the right motor to turn the snowblower chute. I'm not sure what I want to use yet. Now, this feels rinky-dink. This feels pretty small for the task. Spice is, that's a 50 RPM. Basically, I want to be able to turn the chute half a turn in like about 3 seconds, somewhere in there. And it's also going to be geared. Right now, this is kind of going direct drive, but it's also going to be geared with a pulley about a sprocket about this size to like 4.5 to 1, something along that lines. So it's actually going to have more power than the test that we're going to do now by about a factor of 4. So what I've done is I've hooked it up to, and it is actually, it's doing it. Hell. Let's stall. Oh, I got stuck on the chair. So it can stall, but wow, that really wedged in there. Don't know for sure, but that is a promising amount of force, especially once that's geared up. So, all right, so here is the chunk of metal that we just lifted with that little motor, and we'll weigh it official-like. So 3 pounds, 14 ounces, so almost 4 pounds. So we can potentially get 16 pounds of rotating force. All right, so we're getting ready to put on the battery or the control box. So I welded on these little bits of tubing, and I'm going to have a pin that goes down in. Those are the two different boxes that I have. One's an ammo box, one's like a NEMA box. I don't know which size I'm going to use yet. Depends how tight I can fit everything. I kind of like that box better. It's heavier. This one's a little, bendy plastic. And then for our mount, what we've done is we've taken some more of the tubing, we put a pin up inside of it that fits nice and tight, and we've already aligned that. And that one, we're still in the process of welding. It's a random interesting bit. This is where the welder cord was laying, the gun. And there's striations in, that's all the dust, like the grinding dust, so metal magnetic particulate. And it's interesting that it formed that pattern. Is that from the vibration of the wire going through, or is that from magnetism? I don't know. It's interesting though. All right, so here's what she looks like, all the way tilted back. And this does, the little handle hits, but the metal does not. And so I have plenty of room. I can get the batteries in and out, and get my hand in there, get my hand in there. Then with the front end all the way down, I have plenty of room to get in my electric starter without having to rotate anything. From the back, it looks pretty decent. Everything is on the same level there, same height. And there, no, it's not looking too bad. Not so bad. All right, so we have the thing lifted up and supported on some lifting hooks with a spreader bar, and we're about, according to some very precise calculations here, we are this far away from being perfectly balanced. All right, so we're up, and our total weight is about 292 with the extra weight, and our scrap weight is 20 pounds. I really thought I was closer than that. My hook may not have been perfectly over the axle, but I think it was pretty close. I don't know. I don't trust it. I want a better gauge. I'm going to jack it up and put it back on the block. All right, so with it up on blocks, I'm within basically a hammer of just a little bit more thing. One other thing I just thought about is the power chair had a rating of 300 pounds. That was the weight of the user, and that didn't include the weight of the chair. So with this whole thing being 270, yeah, we're right within range of those things. So we're going to go ahead and we're going to try this. I think it'll probably work. I think it should be strong enough because it's geared so low. In terms of gearing, we have this is from the original snowblower. It's one of the internal parts. That's a 7-tooth sprocket. And between the RPM, 50 RPM, 7-tooth sprocket to a 45-tooth sprocket, I should get about 3.8 seconds for a half chute rotation, which it's not too bad. I think it'll be okay. I can always bump that up to a little bit faster. A 64 revolution would give me the 3 seconds that I want. And this is a pretty standard form factor. It comes in all different sizes of gearings. So I could swap this out at any time with a higher or lower one. I also have a 10-tooth coming, but I don't have it here yet. So I'm just going to go with that one for now. And then in terms of enclosure, this isn't by any means waterproof or resistant. So I got to put it in some kind of case, and it doesn't really fit here. It's like we're going to have to do some carving. So we're going to take the Dremel, and we're going to kind of put it in there and trace it around and back. Got to get rid of that, and we got to get rid of some of this, but it's nothing bad. And then I'll show you how we do the mounting in a little bit. Yeah, right, so we've completed our surgery. We popped out the 2 little plastic bits. Now we can fit our motor in there just fine. Next is mounting holes. So how do we get this the easiest way? Anyway, you may have seen this before in one of my other videos. I love to use clear plastic. It's just great. So I drilled a 1/4-inch hole, and I'll put it over there. And now I can perfectly see exactly where all my holes are going to go. And then you can just mark them with a marker, pop, pop, and then drill them carefully. And now you have a perfect template. Then we'll transfer that to a piece of metal that'll go underneath. You'll see that in a second. So put the motor in, figure out where the offset of this is with a mark the center, drill through, put the plate on the bottom, line it up the way you want it, and then mark it through this hole. So now you know where it is in this plate. And then we use our thing to go and lay out a hole pattern. And actually, my first one was just a touch off, so I did a second one. No way. put this through so that way we're lined up, put the plate back on so that, you know, this is a nice tight hole. And we can see we got, let's see if I do it just right. 3 of them are perfect, and this one is just a touch off. So I'll drill this a little bit bigger, and I'll drill that a little bit bigger so I don't get a rub, and everything will work out fine. Well, Home Depot didn't carry the right size thread last night, and I couldn't find any in my scrap bin that were long enough to go through the plastic and the plate. So we ended up having to turn our own down and thread it, you know, with a tap and die set. So make a couple more of those, cut it off and with a hacksaw, and then we'll just put a slot in it for a flat head screwdriver. Whatever. Here is the comedy hour for the day. So yeah, I turn a nice part, turn it off, drops into my pile of mess. I'm like, oh boy, haven't cleaned in a while. Okay, so I pull all that out, I find it, I grab it, I burn my finger because I wasn't thinking, you know, I'm just happy to see it. Then I set it aside. Then I grab Mr. Vacuum Cleaner and I'm like, I'm going to clean up the rest of the mess so that doesn't happen again. And it sucks up my bolt, and now I have to find it or make a new one. Yep. Some days it just goes like that. Victory! Mr. Vacuum Cleaner had a hairball, so it was still in the tube. I did it again. All right, so here's what we came up with for the sprocket. We held it in a collet by this bearing surface, and we soldered off in a sawzall first. Then I turned this down just to get a nice diameter just to clean it up because it was kind of rusted and pitted. And then this little step here is to go through the metal plate and through the plastic. I want as much hole engagement on the shaft as sounds horrible, as I possibly can. Just for kind of alignment reasons, so it doesn't have a wobble, because the plate, you know, we only have a bit of a nub. We only have a bit of a nub sticking out, and while that's okay, that's plenty of room for a set screw. I wanted a little bit more engagement on the shaft for, you know, wobble and stability. All right, so we will next put a set screw in here. I'll drill that plate out first so I know exactly where to mark this. And then this piece should be done. And I think I'm going to keep a bearing surface down here just for any tension, you know, that way the tension of the chain doesn't go into that gearbox at all. It can all be absorbed on this bearing. So there's how much clearance we need to go through both of those. And there's the end of our shaft. And I think I have just enough room to sneak in a set screw. Tight, but okay. All right, well, for such a small part, that took a lot of time. And now I have something I can weld to without